Let's take a look at the relationships between side lengths of a triangle. I'm going to use some pieces of spaghetti to represent the measurements you can see here. So you can see here is my 4 millimeter or a centimeter length, and here is my 7 centimeter length. All right, what we have up here are in order 10, then 11, then 12 centimeter pieces of uncooked spaghetti. These are going to act as our side lengths of triangles. So when I go to put these together, I can make whatever angle I want. I can make acute angles, I can make obtuse angles, I can move these however I need to form triangles. I'm going to start with our longest piece here, and let's see what happens when I try to form a triangle with this 12 centimeter piece. Now, it's important that as we work, we make sure that we keep the edges of the spaghetti together because those are acting as the measurement points. So I can't have them kind of misaligned like this. Clearly, this is too wide of an angle, or too short of an angle, I guess, for this to work. So let's move these on in. That looks a lot better. Need to slide that over. And still having some trouble there. It's still not quite reaching. Maybe if we go a little bit more obtuse, there's just too big of a gap. There's no way these are going to make a triangle. In fact, if I slide these together so that they're even with no angle, they're still not going to touch, much less make, see that gap, much less make a triangle. So there's our 12 piece. Let's set that one out. Now we have the 11. Let's see if the 11 is better. We know we needed a pretty obtuse angle for that 12, so let's start with a pretty obtuse one. We can see that this is going to be a lot closer, but it's still not quite reaching. Let's go a little bit closer. This one wants to keep rolling away, so I may have to hold it. And keep those ends. And then, oh, it's so close. It's so close. But I wonder, I wonder if as we move it, yep, that's what I was worried about. But I guess it kind of makes sense, right? Because we know that that 7 plus 4 is exactly equal to the 11. So it kind of makes sense that they didn't actually form a triangle. So now that brings us to our 10 centimeter piece. And let's see if this one will actually work for us. We'll start off just like we did with the others. And, oh, that's too much of an angle. We need to pull that one back out a little bit. Almost. Hey, there we go. We were able to actually make a triangle this time. So out of all of our options, the 12 did not work. The 11 also did not work, but the 10 definitely did. And this is going to lead us to something called the Triangle Inequality Theorem. The Triangle Inequality Theorem says that the sum of the shorter sides of a triangle must be longer than the longest side of the triangle. So if we look at this side here, AB, and add it to this length BC, it needs to be greater than this length AC. Now, something else you can do that makes it a little easier to think about is name the side by the angle across from it. So this would be A, and we'll use a lowercase a. This would be lowercase b, and this would be side C. So if it helps to think about, we could rewrite this and say that side length A plus side length B needs to be longer than side C. And the same would be true for all these other sides. What you can do when you are trying to test and work with different triangles with specific side lengths is you can take just the shorter sides and compare them to the longest side, and that will help you determine if you can actually create a triangle.